My previous video I talked about salt because it was on my mind. I just study stuff. There's no particular reason why it came up, but uh, what matters is that it's connected with water. Somehow all the salt has collected up in the water, or at least what seems to be the majority of the surface salt that's on the planet Earth, because we do know that there's a lot of pockets of solid salt deposits under the surface, and they go in there and they mine it. This produces a lot of the salt that they use for spreading on the roads, and it causes destruction to the undercarriage of the cars, but it's used for melting the ice during the winter in the northern hemisphere or the southern hemisphere in extreme latitudes. So if you want to study that, how does salt bring up the temperature or somehow affect the water from freezing? I really don't know, but just using logic and common sense, it has something to do with when it gets into the water, it makes the water more dense so that the water molecules cannot form into ice. They just have the salt molecules in the way. So that when the temperature goes down to 32 degrees, and then the water, I'm talking about air temperature, and then the water is getting to 32 degrees, but it still has to cool down the salt before the water will freeze. So I think it has something to do with that. And that's why they put the salt down, because it readily dissolves into water. Water is a solvent, but salt, it just automatically will break down into molecules. It breaks the bonds of the crystal pretty quickly. Just like the opposite, when the water evaporates, salt crystals will easily form. But I'm not so sure about the crystalline capabilities of salt, because I think a lot of minerals are like that. Now, well, it's not all like with the metallic crystals or stuff like that. It requires much more pressure, they say, or higher temperatures, lower temperatures, whatever the case may be. But that's not what this video is about. This video is on water itself, because I think it's equal or even a greater topic of significance. It's significant for us to understand water and to gain an appreciation for it. So for me, I want to know everything that I can about water, from how it is used in biology and living animal forms and plant forms, and I wanted to know just in the chemical structure how through electrolysis that hydrogen can be separated out and the oxygen can be separated out. That's all water is, as far as they know. That water is broken down into those two gaseous elements. Two gases come together and form water, which is a liquid at the typical temperature that you find all around the Earth. That's the median temperature. Average median temperature will give you mostly liquefied water, or liquefied H2O. And lower temperature gives you solidified H2O, which we call ice. And then higher temperatures give you vaporized or gaseous H2O, which is fog or clouds, or just mist, steam, or it depends how hot if it's so hot, then the particles are zooming around. It's a super heated water vapor. I think it would, well, whatever term you use, I think we need another colloquial term to use for that type of thing. But this is really my question. The origin of water, just like I said, the origin of salt. Because there's a lot of theories on it, And if you're having any of your own theories, then make your comment. Or if you've studied any of the approved, favorite theories of modern science through the echelon of academic establishment, which is changing all the time, I know. And I am not sure what the reigning theory is today. I'm not even so sure that there is one. There may be different schools of thought which are, sticking to their idea, but they can be debating amongst the other factions there. So I'm not even sure what they are. I haven't done a lot of research. I actually ended up doing more research recently into the salt question. But on the water question, it's just like over a long amount of time, I've just gathered up lore, I've gathered up facts, scientific information about water. And as I study the development, the theorized development of the planet itself, I want to know about all the different substances. So I would just say this, because in order to know where the water came from, you need to understand how much water there is on the planet Earth. Now, here is a fundamental theory, or if you want to call it a principle, that you need to apply when thinking of water. The quantity of water on the planet Earth has drastically increased. So we have more water now on the surface. I don't know if the water comes from underneath, or if the water comes from up above, or if somehow it's created in the biosphere by some kind of chemical or biological reactions. I'm not sure. So it either comes from under, or it comes from over, or both. Both these theories, or both these origins of water can take place, and water might have a different quality depending on where it's from. They say that in the atmosphere, things are going on with gases, and there's ozone. And as you know, ozone has something to do with oxygen in the higher layers, in the sky, in the air. And what's going on up there is involved with the electricity, the charge of the molecules, how they're charged. And lightning has to factor in, because when you think of thunderstorms, these are exchanges from the solid surface of the Earth, which is the solid. So it's like a battery. It's like a natural, humongous battery, because there's a discharge or a flow of the energy, and we see it instantaneously visually. We see the lightning. And in fact, sometimes there is an exchange which you cannot see because it's not concentrated. And then there's such a thing as heat lightning that they talk about, which is just like a flash of light, but it's not concentrated into lightning bolts. So all this is going on, and there's differences. So we have to understand planetary electricity. I'm not sure what they call that science, but it is a form of meteorology, is a specialty in there. But what I found curious is that people were trying to say, I think it's a misconception, that the lightning comes from the Earth and moves upwards into the air. Because they were shocked, because they said, I thought lightning starts in the clouds in the air and hits the Earth. And then scientists had said, no, it goes the other way. But I think that they're both partially right. I think that lightning goes both ways. It has to. It has to. See, it's the flow. You know, it depends. If you study one lightning bolt during one storm, and it may be an exchange from the Earth just releasing electricity that's going into the air. Or you might study another storm and it's going the other way. So, you know, this is worth studying because I think it has a lot to do with definitely the movement of water in the form of rain, condensation, or even well, yeah, that. I was going to say, like, oh, you know, evaporation, but that's a different process. That just has to do with drying, and probably the thunderstorms don't do much to suck water out. Although I'm not so sure. But when it comes to creation of water, is it possible that during large storms that somehow it's bringing the molecules in the air together to create water? Is that possible? And if people say no, then how are you? What experiments did you do to find out that that wasn't true? Now, we talk about the air that's up above. Let's talk about what's underneath, because this is probably even more fascinating because it's solid and you have to go through into dark hidden places, caverns and you know, like porous material, saturated material. So then you're going to talk about, you know, petroleum and oil deposits. This is also in the material of the substrata, you know, the lower layers under the surface, under the crust. And, you know, if all this stuff is extruding and it exists in there and it can be squeezed out or tapped into with an oil well, then how does it relate to the water? If you can develop these theories and really prove the fact that water is created in those lower levels within the earth, then it's going to connect with the idea where petroleum comes from. So this is really radical because more people have talked about where petroleum comes from, and they have more theories about that. But this is also totally confusing when you talk about the creation of petroleum, because a lot of people think of dinosaurs, you know, they have a trademark for Sinclair, that corporation, and nowadays you have all these corporations, and we're still kind of confused about this misconception that the petroleum comes from dinosaurs or prehistoric creatures. We're still confused in that, but I'm going to give you the fact here that there coincidentally findings of fossilized remains mixed in with the petroleum material when they were extracting it, and so they said it was a fossil fuel. But that does not necessarily mean that it comes from the remains of those animals and plants. It doesn't necessarily mean that. And I think that that is the thing that we need to address when we talk about the origin of petroleum, because I'm pretty sure that it's somehow connected with the origin of water. And the two things, like they say, oil and water can't mix. So if we understand one, it'll help us understand the other, because there has to be a drastic difference. And possibly they may be canceling each other out. Now the composition of petroleum is rather more complicated than the composition of water. But let's just go back to water. We're going to focus on water of what's underneath. And this brings up a whole other question about what is the structure underneath, because we don't even know that. They say there's a molten iron core and it's there and it's underneath the mantle, and you know, the mantle's like the zone of the volcanism, and you've got these plutons in there and you know, all these other structures that they have names for, and how they, you know, they have these lava vents coming out as volcanoes, and you know, magma when it comes out to the surface and it blows out, and you can see it, and it gets into the air, it's called lava. Or if it's in the water, these submarine explosions of the volcanoes, cools down and becomes volcanic rock. Well, it will do that either in the air or the water, and you get lava rock. This is a basic creation of new igneous minerals, and it's igneous. And if the temperature and the heat and this lava has contact with an existing rock formation, it's metamorphic because it morphs it. It transforms what's there and remelts it, and it becomes something else. So metamorphic is like an in-between type of a rock, and the other one is sedimentary. But and that has to do with water and erosion action, just layers and layers and layers, and then it somehow gets compressed. But in the sense of water, how can it get into the earth, get deposited in these areas? Like the aquifers are fascinating because we can't see them. Who's ever seen an aquifer? But they go down and they do these tests. They have to drill, or they use not sonar, but it's very hard to do because even a metal detector can only go so deep when you're looking for metals or other things. The detectors can only probe a certain depth, and that's why we don't know what's under there. We just don't know. So there's a theory of the hollow earth, that there's an inside-out world there with an inner sun, like what we would think of as the core of the heat. But I'm not sure. I'm not discounting it. That would be amazing. It's almost like I want to believe in it, but I don't have any proof. And there's a lot of legends, and it's called Agartha, and it had different names. And there's also legends connected with the pyramids, and I have talked to you about the Atlantean civilization, the ancient one, before they were flooded out. That's also pre-Diluvian. So there's information in the Bible and also from other ancient cultures which tell you all about that. The flood legends are universal. Some people would say there's a localized flood, but no, actually there was a huge flood. So in conclusion, I want to get back to my factual premise that you really have to take into consideration before you make a theory and comment here. Realize that there's a lot more water on the surface of the earth than there ever was several million years ago. In fact, I'm going to give you this statistic and this measurement. The level of the sea we see across the earth, the ocean level, you go anywhere on the earth and it's sea level, because the water just flattens out, gets flat when it gathers up. It's not like a solid mountain, there's different elevations. Water is always at basically the same elevation, called sea level. Now everybody knows that the Pacific's a little bit higher, so they have to equalize. When they do the Panama Canal, they have to lower the ships. This is a number of feet. It's not that different, but general sea level, okay, from where it is, you have to imagine it going down from 12,000 to 15,000 feet. That is several miles. Or for those of you in the metric system, that is like 5, 6, up to 7, wait, am I doing this right? 7 or even 8 kilometers, okay? That's deep. That is seriously deep. And I'm going to tell you right now that approximately probably around 225 to 250 million years ago, the water was that much lower. So you could jump from the beach and it'd be bone dry. There's no beach there. There's no ocean. Just drains all the way. So in some areas of the world, that means that the seashore has receded out away from the coast hundreds of miles. In some places about 1,000 miles, so you can't get to the beach. Your ocean front is that way. You know, you go running 1,000 miles, and all of a sudden you find there's the ocean. I'm being facetious because actually the surface of the Earth has changed a lot, and we can't get into tectonic theory here. We can't get into continental drift, and we certainly can't get into the expanding Earth theory that I love so much. We're just going to stick with water and the fact that there's so much more water today on the planet. How did it get here? What's the origin? Thanks for listening. I hope to hear from you. Share this with all your friends, favorite it, thumbs up, and make sure you subscribe.